What if I told you that the greatest story ever told, the history of our planet, was a book? But there's a catch. The pages are torn out, they're buried, and they're all jumbled up across millions of years. So how in the world do you even start to read that? Well, that's exactly what we're going to figure out today.
So, how do you read a story that's millions of years old? That's the big question, right? It means we have to become geological detectives. Our mission is to learn how to read the clues that the Earth has left behind, clues that are literally written in stone.
Okay, so every good detective needs a scene of the crime. For us, it's the Earth's crust. It's basically this huge library of rock layers, which scientists call strata. And believe me, hidden inside those layers are all the clues we're ever going to need.
So how do these layers even form? I mean, how does a new page get written in this giant stone storybook? It's basically a four-step recipe that's happening all the time. First, you've got weathering. That's when rocks on the surface break down into little bits. Sediment. Step 2 is deposition. Wind and water pick up all that sediment and just drop it somewhere else, usually in flat layers. Then, over a long time, compression happens. The weight of all the new stuff on top just squishes the older layers down until they harden into solid rock. And boom, a new layer is formed. That's a stratum, a brand new page in the history book.
Okay, so we know where the clues are. Now we have to actually learn how to read them. And this is probably the most important thing to get your head around. As a geological detective, you're not trying to find the exact date something happened. What you really care about is the order of events.
This whole concept is called relative age, and it's exactly what it sounds like. It's not about finding a birth certificate that says, hey, this rock is exactly 100 million years old. No, it's about looking at a bunch of rocks and saying, okay, I can tell you for sure that this one is older than that one, and this one is younger than the one below it. It's all about comparison. It's about getting the story in the right sequence.
Right. So our number one job is just to build a timeline. What happened first, then what after that. And to figure this out, geologists came up with this amazing set of rules. Think of it like the official detective's rulebook for reading rocks.
And here it is. This is our toolkit. The 5 big rules that let us take all those jumbled up pages of Earth's story and finally put them in the right order.
Rule number 1 is the principle of superposition. And honestly, it's the easiest one. It's super intuitive. All it says is that in a stack of rock layers that hasn't been messed with, the oldest stuff is at the bottom and the newest stuff is at the top. Simple as that.
The best way to picture this? A laundry basket. Seriously, the shirt you just threw in there is right on top, right? But the one you wore last week, yeah, that's way down at the bottom. Rock layers are exactly the same. Oldest on the bottom, youngest on top. Easy.
All right, rule number 2 is the principle of original horizontality. This one just says that when all that sediment gets laid down, gravity makes it settle in nice, flat, horizontal layers. Which means, if you ever see layers that are tilted or bent or all folded up, that's a huge clue. It tells you that some powerful force must have messed with them after they were already formed.
Just imagine you're pouring sand into a clear box. It's always going to settle flat, right? It's not going to form a weird slope on its own. That's just gravity. And Earth's rock layers start out the exact same way, nice and flat.
Okay, on to rule number 3, the principle of lateral continuity. This one sounds complicated, but it's not. It just means that these layers of sediment spread out in these huge continuous sheets. They go on for miles and miles until they either get really thin or, run into something like the edge of a basin. The point is, a rock layer doesn't just suddenly stop for no reason.
The Grand Canyon is the perfect example of this. You've got this massive canyon that a river carved out. But if you look at the rock layers on one side and then look across to the other, they match up perfectly. Because of lateral continuity, we know they used to be one giant connected layer before the river cut through.
Now for rule number 4, the principle of inclusions. This one is a really cool clue. If you're looking at a rock and you see little bits and pieces of another rock trapped inside it, well, the main rock has to be younger than those little pieces. It makes total sense when you think about it. And this is maybe my favorite analogy of all. It's the chocolate chip cookie roll. Think about it. You can't bake chocolate chips into a cookie unless you have the chocolate chips first. The chips had to exist before the dough. It is the exact same thing with rocks. The little bits, the inclusions, had to be there before the rock formed around them.
And our last rule, number 5, is the principle of cross-cutting relationships. This one is super simple, but also super powerful. It just says that if one geologic feature cuts across another one, the thing doing the cutting is younger. So, a crack in the rock is younger than the rock itself. Imagine a big, layered cake.
You have to bake the cake and stack the layers before you can cut a slice out of it. The cut is the last thing that happens. So when you see a fault line, that big crack cutting through rock layers, you know with 100% certainty that those layers were there first.
So there you have it. That's the detective's rulebook, the 5 big principles you need to read the story of the Earth. So, I think it's about time we put you to the test and actually crack a case.
Okay, detective, this is your moment. I'm going to lay out the scene for you. Use those 5 rules we just talked about and see if you can figure out what happened.
Okay, here's the crime scene. You find 3 flat rock layers, one on top of the other. There's a fault, a big crack that cuts through the bottom 2 layers but not the top one. And one more thing, that very top layer has little pieces of the bottom layer stuck inside it. So, think about those rules.
So, what's the sequence of events here? From the very oldest thing that happened to the very youngest. What came first? What happened last? Go ahead, take a second and think it through. What does your rule book say?
All right, you ready for the answer? Let's break it down. First thing that had to happen, the bottom layer formed. That's our foundation. Then, according to superposition, the middle layer formed right on top of it. Simple. Then, that fault cracked through them both. How do we know it happened then? The principle of cross-cutting. The crack has to be younger than what it cuts. And finally, the very last thing to happen was the top layer forming. We know it's the youngest because of superposition, but also, remember those little pieces of the bottom layer inside it? That's the principle of inclusions, telling us that top layer had to form last. And just like that, case closed.
And that's it. That's how you do it. You just took what looked like a confusing jumble of rocks and you laid it out in a perfect timeline. You didn't just look at a cliffside, you read a page from Earth's diary.
So next time you're driving and you see one of those big road cuts on the side of a highway, or you're walking along some cliffs, don't just see rocks. Stop for a second, because now you have the rule book. You know how to read the story that they're telling. The history of our planet really is written in stone all around us. The question is, what story is waiting right beneath your feet?